In this video, we're going to talk about what are called inverse functions. To take the inverse of something is, in a sense, to undo it. And the key is with an inverse function is you switch x and y. So for example here, if I have the relation 3, 2, 4, 1, and 5, 3, the inverse, which is indicated by r to the negative 1, is just the switching of x and y. So my inverse relation would be 2, 3, 1, 4, 3, 5. Notice also the domain and range will switch. The domain of my original relation is 3, 4, 5. Sorry about that. And the range is 2, 1, 3. If we look at the domain of my inverse, the domain is 2, 1, 3, and the range is 3, 4, 5. X and Y have switched. When you look at this graphically, I'm going to graph my original relation in blue. I can graph 3, 2, I can graph 4, 1, and I can graph 5, 3. And then if I graph my inverse in purple, I can graph 2, 3, 1, 4, and 3, 5. And what you'll notice is they are mirror images across the line y equals x. Again, this is because we have switched x and y. When given the equation, we can follow these steps to find the equation of the inverse. First, you want to write the equation as y equals, not f of x, or have x and y on the same side. Then you want to switch x and y. You're going to resolve for y, and then replace y with f inverse of x. As an example, let's take the function f of x equals x minus 1 cubed plus 2. Step 1 is I'm going to write this as y equals. Now I'm going to switch x and y, which gives me x equals y minus 1 cubed plus 2. I will resolve for y. So to do that, I'm going to subtract 2 from both sides, which gives me x minus 2 equals y minus 1 cubed. I'm going to have to take the cube root of both sides, which leaves me with the cube root of x minus 2 equals y minus 1. And last but not least, I add 1 to both sides, leave me with y equals the cube root of x minus 2 plus 1. And last but not least, I put it in the proper inverse form with f inverse of x equals the cube root of x minus 2 plus 1. Again, if you're worried about domain and range, in this case, while there is a radical, it is an odd root, so our domain would be all real numbers.